Advanced Algebra, Chapter 7, Lesson 8. We want to wrap up this chapter by looking at how we can solve these radical equations or functions by graphing, and then looking at rewriting radical functions in order to help us see some shifts that get hidden when we apply a a horizontal stretch. And we'll talk about that in a little bit. Real quickly, solving a radical equation by graphing is something we've done before as far as solving by graphing. When we have two sides of an equation, we use our calculator. We enter in one side of the equation as y1. We'll enter in the other side of the equation as y2, and then we'll use the intersection function in order to calculate the value of the intersection, or where they are equal. And again, most times these problems are set up for us where they describe or give us an equation such as t of h is equal to 2h over g. It tells us in the instructions what each letter represents. So t is the number of seconds, so the output of this function is going to be time in seconds, and it's the time that an object takes to hit the ground falling from a height h. So h is going to be the height that the object has fallen from in meters. The height has to be in meters. The g value of the equation, they tell me, is 9.81. So all of your equations like this, the little paragraph describes the equation, it describes the variables of the equation, and it's important that you take time to read that and understand what the letters represent, and so you know what letter is what. Now in your calculator, you know that we only put in x, and so this would be our x value is going to be the height from the meters. So if I need a height, I'm going to put in that for h. On my calculator, that will be the x value of the intersection, and then the time that it takes is the y value. So when I look for the intersection, the y point is going to be the time that it takes. And so again, we can substitute in either value and solve for the equation. It says solve for t of 7, so we solve the equation for 7. T is the time that it takes, so you'll notice that it goes in on the left. The equation on the right, after substituting in the 9.81 that I'm given for g, I have the h. So when I substitute this into my calculator, I put the left side in as y1 and the other side in as y2. That order doesn't matter. We have the intersection point here. We calculate that, and notice it gives me an x-coordinate and a y-coordinate. And this is why it's important to know what each value represents. What is the answer? The y value is the 7 that we substituted in. That's the time that it takes, and the 240 then is the x value, or in this case the h. The 240.345 is the height measured in meters that this object fell from. So again, it's important to read the instructions, read the description, understand what each of the values represent, so that when you go to answer the question and you have these two numbers, you know which one to use and what each number represents. Okay, we've done that earlier this year, so not a whole lot new there. So y1 and y2. The second thing that I want to talk about is how do we rewrite these radical functions. And sometimes we have to rewrite it so that we can actually see the transformations. In other words, as we look at this equation here, we have the square root of 4x minus 12. Now, because this 4 is on the inside, you remember we used to have it on the outside, or you've seen it on the outside, and that's a vertical stretch. When the number is multiplying the x value, that's what we call a horizontal stretch or shrink. And the problem with, or the funny thing that happens, I guess, if it's funny, not haha funny, but interesting, I guess, is when you multiply, or when you apply a horizontal stretch to a graph, you're multiplying the x value by 4, it also affects the horizontal shift of the graph. So this 4 is affecting the shift as well. And the only way for me to see what the actual shift is to remove this horizontal stretch that's happened. So what I have to do is I need to factor out this 4 so that I can see what the horizontal stretch is, or transformation is, because remember, a horizontal transformation is x minus, and then in here we have the horizontal transformation. Well, if I apply a 4 to the horizontal as a horizontal stretch shrink, I multiply the 4 times x, that's 4h, and I also have to distribute it to this, so I get minus 4h. So you can see that the shift has been affected by the 4, as well as the horizontal shape of the graph. So in order to see what the actual shift is, I have to get it back to looking like this. And the way to do that is to factor out this 4. Okay, so when I factor out the 4, I have 4 times x minus 3. Now, because this is multiplication, I can apply the square root to these separately. So I can take the square root of 4. It now comes outside as 2. And now I can see what the shift is. This is actually a shift to the right 3. And now what I have out here is a vertical stretch of 2. So just a little side note here, a vertical stretch of 2 has the same effect as a horizontal stretch of 4. Okay, interesting thing that happens there. So anyways, this is what we do. This is what we call rewriting the graph so that we can see what the transformation is. So I just showed you that example there. So after I factor it out, this would be a shift of this graph. This would be the original function, 3 units to the right. So now I can see the shift. So in order to see, this is rewrite the function to make it easy to graph using transformations of its parent, and then describe the graph. So if we're looking at this first one here, this 25 needs to be factored out. So if I take out, or I factor out the 25, that's going to give me x minus 4, and then minus 1. And now I can take the square root of 5, which is, or square root of 25, excuse me, which is 5, x minus 4 minus 1. Now it says to describe the graph. So this is going to be a vertical stretch of 3. No, where did I get 3? I have no idea where that came from. A vertical stretch of 5. This is going to be a horizontal shift going to the right 4, and then this is going to be a vertical shift of up, or excuse me, man, I've got this all backwards in this. Vertical shift down 1. So again, this is the one that I have trouble seeing as long as this number is in the way. So factor out that number, take the square root or cube root if you can, then you can see what the vertical shifts are, vertical stretches are, horizontal shifts. Okay, number 59 here, just to take a quick look. Again, I cannot see the shift here because I have some other stuff going on here. So just as a reminder, when you have a fraction that looks like this, remember we can separate this into x over 4 and 1 minus 4. Now, another little thing I can do mathematically is I can rewrite this as 1/4 x minus 1/4. So now I can see what I actually want to factor out. And I want to factor out a 4th because, again, this x needs to have a 1 coefficient in order to see the shift. So if I factor out 1/4, that means I have to divide by 1/4. So if I divide each of these by a 4th, this ends up being this. I can then take the square root of that if I wanted to go further. So 1/2 x minus 1. So now again, once this coefficient is a 1, I can see that the shift of this is actually a shift to the right 1. Okay, one more example. Look at number 69 here, or 61 here, real quick. I have x over 9, again, plus 1. Again, in order to see the shift, I need to factor out this thing that's being done to the x. So again, I can rewrite this as 1/9 x plus 1. I then need to factor out the 1/9, so that's going to be 1/9 factored out. Now 1 divided by 1/9 means multiply by the reciprocal, 1 times 9, so this would be a 9. So now that I've factored it out, I can actually see, well, one more step I could if I wanted to. The square root of 1/9 is 1/3, so x plus 9. So now that I can see that the shift of this graph is actually to the left 9. So again, no different. Whatever this value is in front of the x, if it's not a 1, we need to factor it out of both the x and the shift term so that we can accurately see what the shift of the graph is.